So it's possible that I'll give you a 3 by 3, as long as the numbers work out really well. I think these will work out okay, but I haven't done it yet. So the first step is still the same if you have 3 equations. You make the augmented matrix 1, 2, 1, 2, -1, -1, 3, 0, -4 with the answers on the other side. Now the goal is to have this matrix diagonalized in this format where there are whatever the answers are here. Now, knowing that, hold on here. There we go. Knowing that, we can do something here. Notice that there's a 0 here. Well, that's okay. We want it to be 0. If it had been in the middle, say it had been 2, 0, 1, you can change the order of this equation. Right? You're allowed to interchange rows. You can change the order of the rows at any time. And that should make perfect sense because it doesn't matter which equation is first, second, or third. So you can do that to make things easier. For us, it's already set. All right. So here's how it goes. We want this to be equal to 1. Check. It's done. All right. Next step, we want this to be equal to 0. That's not done. So I'll take row 2 minus 2 times row 1. So notice that row 1 is not going to change. Row 3 is not going to change. Row 2 is. This will be 0. Then I have minus 1, minus 2, minus 4, sorry, that's minus 5. Then I have minus 1, minus 2 is minus 3. And then I have 3 minus 2 is 1. So then the next step is to make this one equal to 0. To do that, I'm going to I'm going to take row 3 minus 3 times row 1. So that doesn't change row 1. It doesn't change row 2. It does change row 3. 3 minus 3 is 0. 0 minus 6 is minus 6. And then minus 4 minus 3 is minus 7. And then 1 minus 3 is minus 2. Okay? All right. Now our next goal is to make this one equal to 1. So let's try to conserve some paper. So we'll do that by taking negative 1/5 times row 2. That leaves the top row the same. And it leaves the bottom row the same. And then we'll have 0, 1. Then we'll have 3/5 and negative 1/5. All right. Next goal is to make this equal to 0. You should kind of notice what we're doing here, right? We want 1, 0, 0, so we do that. And then we are going to deal with this in a second, but we do want this to be 0, 1, 0. So we could do this one first. It doesn't really matter. So we'll do row 3 plus 6 times row 2. So you see how that 1 is being used. So see the top row is the same, and the middle row is going to be the same. And then we're going to have 0 plus 0 is 0. And minus 6 plus 6 is 0. And then what's this going to be? We have a minus 7 Now we have 6 times, maybe I'll just write it in here, minus 7 plus 18 fifths. And then we'll have minus 2 minus 6 fifths. So what is that? That's 35 fifths. So is that 17? So that's minus 17 fifths, right? 35 looks right. And then this, well, that's negative 10 fifths. So that's negative 16 fifths. All right. Next up. And this is super boring to watch. We want this cell to be 1, or I guess that one's 0. Well, we'll get back to it. Make this a 1, and we'll do that by taking row 3 times the reciprocal. So we'll do negative 5 17ths times row 3. And the first row doesn't change, the second row doesn't change, the third row is 0, 0, 1, and then we have to muck around a little bit here. Not too bad actually. Right, we have 2 negatives, that's positive, the 5's cancel, so it's 16 17ths. Okay. Next goal is to make this one equal to 0. And we'll do that by taking row 1 minus 2 times row 2, using that 1 to take a multiple of it. So let's see, what doesn't change? The second 2 rows don't change. 0, 0, 1, 16, 17. And so 1 minus 0 is still 1. 2 minus 2 is going to be 0. 1 minus 6 fifths is going to be minus 1 fifth. And then what's this? This is going to be plus. So it'll be 1 plus 2 fifths is 7 fifths. Almost done. 2 more steps. Let's do, we can do this one, make this one equal to 0. So to do that, we're going to take row 1, and we'll do plus 1/5 of row 3. So row 3 has the 1 times the 1/5. It's going to cancel this out. These zeros don't do anything. And then, of course, this mess will combine with that mess. So not much changes, actually. The second 2 rows don't change. Negative 1/5, 16, 17. The 1 and the 0 don't change. The negative 5th plus a 5th is a 0. And then we just have this stuff. So we had 7 fifths plus 1/5 of this garbage. So, oh, that's lovely. 5 times 17. Okay, so common denominator is going to be 5 times 17. What is that? 85. So this is 85. 17 times 7 is 119. So this is 119 plus 16 over 85. So 135 over 85. Whew. That's lovely. Almost done. Probably hard to believe, but people used to. You used to have to do this out. Go back, how long? Definitely before the 50s. Things like the Hoover Dam, for example, the San Francisco Bridge, were done without any calculators. So if you had anything like this to do, you had to do it by hand. Good time to be alive. Alright, so the last step is I want to turn this into a 0, which I'm going to do. So I'm going to do by taking row 2 minus 3/5 of row 3 using that 1. So the first row doesn't change, 135 over 85, right? Lost track rows here. The last row doesn't change, sorry, 0, 0, 1, 16, 17. And this, well, we have 0 minus 0. We have 1 minus 0. Now 3/5 minus 3/5 is 0. And then what do we have here? We have minus 1/5 minus 3/5 of 16/17. So that's going to be, minus 17 minus, what is that, 48 over 85. So that's 58/65 minus 65 over 85. So our solutions are x equals 135 over 85, y equals minus 65, 85, z equals 16 over 17. We can simplify this. 5 goes into the top. 27 times 5 goes into the bottom. 17. 5 goes into the bottom. 17. 5 goes into that. 13. And then we have 16/17. Yeah. And these are correct. I did this one ahead of time. So, wow. That's the most tedious problem I could possibly ever ask you to do. And as you can see, it took, over 10 minutes. So, not a good test question, but, well, I could ask a test question if there were more zeros in here. I'll show you another example of that.